Hello, in this video on linear programming, we will learn how to find the minimum and the maximum values. So if you look, for instance, at this example, you've got your three inequalities and you've got the shaded areas, and inside here, an unshaded area is formed. Now, number one, this unshaded area is what we call the feasible area or feasible region. That means, people, this is the region that we can work with. Okay, now if you look at any of the integer coordinates inside this region, so that must be always whole numbers, people. We do not work with fractions or decimals here. We will always find coordinates that are exactly on points of intersection of your grid, so that we find integer values, okay? Any of these, okay, will actually give you a solution to your inequality or the expression that you are working with. But importantly, the minimum and the maximum value you will find on the vertices or close to the vertices of your feasible region. So in this case, I am showing 1, 2, 3 points. These 3 points will give you the minimum and the maximum value for a certain inequality. So let's look at this example. It says, from the diagram, give the coordinates of the vertices of the unshaded region. So I have already indicated them, okay? Those are the 1, 2, 3 vertices. And you can just read them off. This is 4, 1. This one is negative 2, 2. And that one is negative 2, 5. Okay? We have written them down. Because my region is bound by a solid line, I can actually take vertices on coordinates on the vertices. This is important because if it is not a solid line, people, that line is not included. Then you must take a point that is close to a vertex. Okay, I repeat, because these are all solid lines, I can actually take points on the vertices. That will give me the 3 coordinates on the vertex. Okay, now they're asking, at which vertex is the value of x plus 3y a minimum value? So x plus 3y will be solved by any point inside here. Okay, so at which point is it minimum? So all you need to do, you take your 3 vertices, you substitute that into your equation there, or expression I should rather say, and you work out your answers. So if you look at the point, for the point negative 2, 5, my answer is 13. For the point negative 2, 2, my answer is 4. For the point 4, 1, my answer is 7. And they have been asking me the minimum value. So the minimum value, people, is 4. Therefore, my point negative 2 and 2 will give me the minimum value. Then in the next question, they ask which vertex will give you the maximum value. So once again, we go back where we have calculated each coordinate, and we see the maximum is 13. So the coordinate that will give me the maximum value will be negative 2 and 5. Right, then they say write down the coordinates of all the other points in the region whose coordinates are integers, which means, people, you can go to any of these. Okay, that one, that one. So let's use, for instance, this one, that is negative 1 and 3. Okay, this one is negative 2 and 3. This one is negative 2 and 4. So you can write down all of these points. If you look at the answer here, there are quite a lot of them. Okay, and then they ask you to work out whether for the expression x plus 3y, any of these other points that you now written down here will actually exceed the minimum or the maximum value. That will be done by substituting each and every one of these points. And when you look at the answer again, you will get 7, 10, 5, 8, 11, and so forth. But if you look at that, you will not get less than 4, which was the minimum value, and more than 13, which was the maximum value. So with this, we prove that your minimum and maximum will be the vertices or close to the vertices. Okay, I want to go on with the next example where they say in the region defined by y is less than x plus 3. Okay, so this is this one. It's a dotted line, careful. Then 3x plus y is less than 6. 3x plus y is less than 6. It's also a dotted line. And then y is greater than or equal to 1. Y is greater than or equal to 1. This is y equals minus 1. And the shaded areas are on the outside. So once again, this unshaded part here is my feasible region. And remember, I am working with the feasible region. Okay, now really important. You cannot, for maximum and minimum values, choose, for instance, this point, people, because this point is on a dotted line, and the dotted line means it is not included. So this point is not possible. This point is not possible. This point is not possible. That point is not possible. But this point is possible, and that one is possible. So you can, in this case, because those are dotted lines, not choose a point on the lines. You must choose a point or points close to the lines. However, if we look at the bottom here, this is a solid line, meaning, people, you cannot choose this one because there is still a dotted line, meaning you can now choose this one as well as that one. Okay, those are the points closest to the vertices. All right, now you must find integer coordinates where 3x minus 2y is a maximum. So for number 1, write down your 4 coordinates closest to vertices or on the vertices, which gives me -3, -1, -3, -1, 0, 2, 1, 2, and 2, -1. Okay, and then to find the maximum, remember we must substitute. We will take our expression 3x minus 2y. Okay, write down all your coordinates, substitute them into your formula, and get your answers. So for the 4 coordinates, my answer is -7, -4, -1, and 8. All right? And which one represents the maximum value? The 8 represents the maximum value. So the point that gives me the maximum value is 2 and -1. Okay? 2 and -1. So this is fairly simple. I repeat, what is the steps that you must do? You must find the points or coordinates, I should say, either on a solid line, okay, or next to a dotted line, but you must find it as close as possible to the vertices, the corners of your unshaded area, or what we call the feasible area. Okay, write those coordinates down. Then to find the minimum and maximum value, you will simply substitute each of the points into your expression and you will calculate how much it gives you, right? And then your maximum value will be the greatest possible answer. Your minimum value in this case is then the -7. So that will give you the coordinate will give you the minimum value.